Okay, let's give you guys some more practice. So find the radius of convergence on the interval of convergence for this series. So press pause and have a go. Okay, so to do this, we need to use a ratio test. So when it comes to the ratio test, we always need to compute this value here. We always need to get an plus 1, so this is your an plus 1, divided by an. Well, dividing by an is the same as multiplying by the reciprocal of an, which will be this. So now it's just a matter of tidying this whole thing up. If you look at this bit here, and then this bit here, if you combine the two, it's either going to be -1 or it's going to be 1. And when you take the absolutes, you can pretty much ignore this block and ignore this block. Now look at this block here. Visualize this. Visualize this as being x to the power of n times x. And then look at this block. Visualize this as being 4 to the power of n times 4. So now you can see that this will cancel out with this, and then this will then cancel out with this. So that would, and then group all the n's together. Group all the n's together. So that will then take you to here. That will then take you to here. So you've got your x here, and then you've got your 4 here and 4 here, and group the n's together. That will then give you this. Now, because n is always n is always positive, so you can take the whole thing here out of the absolute sign. So that will then give you this. Now, when it comes to the ratio test, for convergence, we require this to be strictly less than 1. That means for convergence, we require this to be less than 1. But as n heads towards infinity, you can see that this thing here will head towards 1. It will head towards 1. So you trying to make this to be less than 1 for convergence. For convergence, we require this to be less than 1. If you're trying to make this to be less than 1, just concentrate on making this to be less than 1. The minute this is less than 1, then the whole thing here will automatically be less than 1. So you trying to make this whole thing here to be less than 1 for convergence, just concentrate on making this to be less than 1. So for convergence, we require this to be less than 1. So for convergence, we require this to be less than 1. So now whenever you see this, you can always translate it to this. So now times everything by 4, that will then give you this. So what that means is anything in between -4 and 4, we know for sure the series will converge, for sure. But we need to check what happens when it's dead on -4 and 4. Because dead on -4 and dead on +4, this thing here, dead on -4 and +4, this thing here will equal 1. So when it comes to the ratio test, when this equals 1, it will be inconclusive. Remember, when this is less than 1, we have convergence. When it's greater than 1, it's going to diverge. When it's 1, it's inconclusive. So it could converge, it could diverge. So we need to manually check what happens when it's dead on -4 and what happens when it's +4. So we now need to check what happens when x equals -4. So going back to the original series, we need to put this into the x here. That will then give you this. So now to the power of n, that means you can just merge these two together. Just so -1 times -4, that will be +4. So this block here cancels out with this, giving you this. So we've done this before. So now it boils down to you deciding whether this will converge or if this will diverge. We've done this many times. Here you should use a direct comparison test, because if you look at natural log graph and y equals x, well, natural log here, this is y equals x, this is natural log of x. You see, we should compare this with 1 over n. You see, n here will always be bigger. This denominator here will always be bigger than this. So that means this thing here will always be less than or equal to this thing here. Well, we've done it many times. For you to decide if this will converge or if this will diverge, you should use the direct comparison test. So this thing here will always be less than or equal to this. Well, we know this is going to diverge. We've seen this many times. Well, this being less than this will have no choice but also to diverge. So we know that we know that this is going to diverge for sure. So now we need to check what happens when x equals 4. Going back to the original series, well, when x equals 4, we would put this into here. That will then give us this. So same power, no, actually, don't do that. This will then cancel out with this, giving you this. So now this is the alternating series. So we should use the alternating series test. So now it brought, sorry, hang on. So let's go back a few steps. So this will cancel out with this. So that will then take you to here. So now we need to decide whether this will converge or this will diverge. To decide, we will need to use the alternating series test. So with the alternating series test, you ignore the positive negative one thing and just extract your un. So you ignore this and just extract your un. So your un equals this. Make sure all the u's are positive. This will always be positive, so that's good. Check number 3. Make sure that is heading towards 0. As n tends towards infinity, this whole thing here, this will get bigger and bigger and bigger, making the whole thing getting smaller and smaller. It will head towards 0. So number 3 is good. Now we need to check that the next term is always less than or equal to our current term. Basically check that it's non-increasing. Think about it, it is actually non-increasing. We've done this many times. So all 3 conditions have been met, therefore we know that this is going to converge. So summary of all we've done. We know that anything in between here, we know for sure is going to converge. We then checked for dead on -4. For dead on -4, we know it's going to diverge. And then we checked on what happens when it's dead on 4. Well, dead on 4, we use the alternating series test, and it turns out to converge. So this dead on 4 it will converge, -4 it will diverge. So your radius of convergence, is 4, and your interval of convergence, well, exclude the -4, but include the 4, So your interval of convergence is this, radius of convergence is this. Okay.